Vertical turbine pump is a centrifugal pump that specialized designed to move water from well underground or reservoir. It is designed to move clear water, rainwater, water in iron sheet pit, sewage, and seawater which is under 55 Celsius. But it also has special design that can be available for media with 150 Celsius. It has capacity 30 to 70,000 meter cube per second and height 5 to 220 meter. It can be used for all types of applications, from moving processed water industrial plant to providing flow for cooling tower at power plant, from pumping raw water for irrigation to boosting water pressure to municipal pumping system, and for virtually every other imaginable pumping application. The advantages of vertical turbine pump are: 1. Motor are safe during flight condition. 2nd. Vertical turbine pump have no primary coil and it is submerged condition. 3rd. Height, flow, and head range in vertical turbine pump compared to horizontal turbine pump. 4. It does not require a lot of installation. 5. Pump have high lifting capacity. 6. The chance of misalignment is less as vertical condition have self-guide groove for motor alignment. The pump are usually driven using induction motor or by a diesel engine through a right angle drive. The pump end consists of this one rotating impaler that is attached to a shaft and direct the well water into diffuser casing called a bowl. Multi-stage configuration use multiple impalers on the same shaft to create higher pressure that would be needed for deeper well or higher requirement pressure at ground level. When water enters the pump at the bottom through a bell-shaped part called the suction bell, vertical turbine pump will start to work. From there is moved into the first stage impeller, which raises the water velocity. The water then enters the diffuser bowl immediately above the impeller, where the high velocity energy is converted into high pressure. The bowl are direct fluid into the next impeller located immediately above the bowl, and this process continues through all stages of the pump. Later, when the water leaves the last diffuser bowl, it passes through a long vertical column pipe. As it rises up, the well bore toward the surface. The spinning shaft inside the column is supported at 3 or 5 foot interval with sleeve bushing that are mounted inside the column and lubricated by the water moving past them. At the surface is the pump discharge head, which allows the flow to change direction towards the discharge pipe.
Hi, so I'm going to share with you the type and usage of the vertical turbine pump. First and foremost, I'm going to show you the type of vertical turbine pumps. There are 3 models that are commonly used. The first one is the VIT, short set line shaft turbine pump. Next is the VIC, can line shaft turbine pumps. And lastly, VIS, submersible vertical turbine whirlpool pumps. I'm going to explain one by one in detail, so stay tuned. The first one is the VIT, short set line shaft turbine pump. Wet pit and open sump pumps benefit from multi-stage line shaft vertical turbine pumps. The hydraulic components of line shaft vertical turbines are immersed in the pump fluid, but the motor is above ground, making electrical components easy to reach. For applications with greater temperatures or variable fluid characteristic, this form of pump offers greater material and configuration versatility than submersible pump and motor combos. Depending on the application, line shaft column assemblies can be open or enclosed. There are several applications for this type of vertical turbine pump, which are industrial process pumps, industrial or commercial water supply, filter backwash, plant water system, water parks, as well as dewatering and flood control. Next is the VIC, can line shaft turbine pumps. Multi-stage can vertical turbine pumps are perfect for closed-loop boosting and offer the same adaptability and performance as the line shaft pumps. These are short set line shaft pumps with suction pipe work linked to a can or sleeve inlet, allowing the pump reservoir to be created by the can. A can turbine pump is an excellent choice for sites that have suction pipes but no existing sump or reservoir. There are several engineered for complex application for this type of vertical turbine pumps, which are industrial process pumps, municipal water and wastewater, utility circulating water, plant water system, and condenser circulating water pumps. The last one is the VIS, submersible vertical turbine boreholes pumps. It is ideal for deep set application where line shaft pumps are not feasible. The entire device is buried, resulting in a space-saving and quiet operation. It is also long-lasting and low maintenance, no lubrications or alignment required. The application includes municipal raw water supply, industrial raw water supply, irrigation, and dewatering. Now, I'm going to tell you the usage of vertical turbine pump. Vertical turbine pumps are typically employed in locations where submersible pumps are not feasible. This is frequently because the flow is too high for turbines or the owner prefer a traditional top-mounted motor. Vertical turbine pumps are used in bore wells to provide irrigation for agriculture or turf. It is also utilized to provide groundwater for communities that don't have access to surface water, as well as plant makeup water and fire water for industrial operation. The application of vertical turbine pump is not only for bore wells, but it also can be used for an open channel such as reservoir, river, or pump intake structure. In industrial situations, they can be positioned on top of a tank, or they can be installed inside a barrel for greater control of suction, source pressure versus atmospheric pressure. Lastly, the pump can be used as a booster pump for community water supply or in an industrial application where pressure head must be increased. It could also take suction from a vacuum-sealed vessel such as a hot well condensate pump. Vertical turbine pumps have flow rates ranging from 50 gallon per meter to 30,000 gallon per meter and higher due to the pump that can have one or more stages, and the quantity of heat it generates may be modified.
That's all from us. Thank you for listening.